Good day, guys. Today our topic is about what is transformer percent impedance voltage, how it is measured and calculated, and when and how it is used. So we have here a transformer nameplate. Given are the following: rated power 800 kVA, rated primary voltage 6600 volts, rated primary current 70 ampere, rated secondary voltage 400 volts, rated secondary current 1154.7 amperes, and the impedance voltage, which is 5%. So let us see the kinds and types of transformers. Even if transformers looks like this, a small transformer or a medium power transformer, or even a large transformer with a conservator tank, all of them will have the same diagram when drawn. So this is the diagram of the single phase transformer with core. Even if it is a dry type or oil immersed transformer, the diagrams are all same. So now let us start with the transformer short circuit test procedure. Let us start with this one. Let us not define, so you will understand how is this test is done. So the first step is to short circuit the secondary winding of the transformer. Make sure it is a voltage short circuit. You can do it either in the high voltage or low voltage side. It can be selected to be short circuited, but LV is more convenient. So this is the diagram. Primary winding, high voltage. In the secondary winding, we have the low voltage. And we have to short circuit the secondary current. This time is the low voltage winding. As mentioned, we can do it also in the high voltage winding, but it is more convenient in the low voltage. Now the second step is to connect an ammeter in series with the high voltage primary winding. This is for the reading of the primary current. And the next step is to connect a voltmeter in parallel with the high voltage primary winding. This is for the reading of the primary voltage. And the fourth step is using a variac or variable voltage source suitable for the required test. Gradually adjust the input voltage from 0 volt to a voltage value that will generate the rated or full load current of the primary winding. Stop the variac adjustment. So it is adjusted here, the voltage, until we get the rated primary current, which is in this case is 70 ampere. The next step is record the voltmeter reading. This voltage is called the impedance voltage. So the reading taken after adjusting the primary voltage and the full load current rating is reached. So this voltage is called the impedance voltage. In this case, we get 330 volts. And let us keep in mind that the rated primary voltage is 6600 volts. Now to calculate the percent impedance voltage, by dividing it by the rated primary voltage multiplied by 100. So percent IZ or percent impedance voltage. So 330 volts, which is our impedance voltage, divided by 6600. This is the rated primary voltage. Multiplied by 100, so we get 5% as shown in the nameplate. So what is percent impedance of a transformer? Now we can define it, since we already understand how it is taken, or how it is calculated, how it is measured. It is the voltage drop on full load due to the winding resistance and leakage reactance, expressed as a percentage of rated voltage. What are the effects of impedance of a transformer? So if the transformer have a high impedance, it can reduce short circuit currents, but they can also cause system stability problem. If the transformer have a low impedance, transformers are typically more efficient and have lower losses than of higher impedance transformers. Now, what are the other uses of transformer impedance? One important role of parallel operation of transformer, one important role of impedance is if the ratio QA rating to percentage impedance between two transformers. If they are equal, they will share equal load. But if they are different, they will share the unequal load. So there is a tendency that the one of the transformers may result in overheating. Also, it is recommended that transformer planned to be operated in parallel must be identical. What this identical means? This means that they must have, number one, same capacity. They should have same kVA, same MVA, or same VA. And number two, they must have the same primary and secondary details. Number three, they must have the same percent impedance voltage. And number four, they must have the same vector group. So let us see a calculation example using percentage impedance voltage. So here, the question is, what is the maximum fault level available in the secondary of the given transformer? This nameplate that is given before, we will use this nameplate. Knowing the capacity of transformer, the secondary voltage, and the percent impedance voltage, short circuit current can be calculated as I short circuit for 3-phase is equals to the MVA short circuit divided by square root of 3 times the kV of the line-to-line voltage. So this is the transformer nameplate which we are going to calculate. Now I short circuit for 3-phase is equals to MVA short circuit divided by square root of 3 times the kV of line to line. So we have a given 800 kVA transformer. So converting it into MVA, we have 0.800 MVA. And the given 400 volt secondary line to line voltage, converting into kV, we have 0.400 kV. And using the percent impedance voltage or percent IZ, which is equal to 5%, short circuit MVA, we get 0.8 MVA divided by 0.05. This 0.05 now is the per unit equivalent of 5% impedance voltage. So here we get 16 MVA. Now the maximum fault current I short circuit is equals to 16 MVA divided by the quantity square root of 3 times 0.4 kV, and it results into maximum fault current I short circuit 23.094 kiloamperes. Now let us check if we know only the rated secondary current and the percent impedance voltage, short circuit current can be calculated directly. Just divide the rated secondary current by the percent impedance voltage or equivalent per unit value of this impedance voltage. So maximum fault current I short circuit is equals to the rated secondary current, which is 1154.7 divided by 0.05 per unit. So we get here 23,094 amperes, or in kiloampere it is 23,094 kiloampere. So let us note that per unit is the same as percentage. Only a factor of 100 is the difference. So if you have 5.4%, that will be 0.054 per unit. You have to move 2 decimal places to the left. So I hope that you learned something about percent impedance voltage. I hope that you understand and you now know how to apply this value per percent impedance voltage, which is found in our transformer nameplates. Thank you, and I hope that you will subscribe to learn more about the topics that I am going to discuss. Thank you, and God bless.